Good morning, everyone. Welcome to the e-research Summer Hackfest. It's been quite a nightmare to have everybody here in the room, but I'm very happy that you made it and got to Catania. I think that we have a very dense program, at least for the first 3 days. So I would like to introduce Professor Piranello, who is the director of the Department of Physics and Astronomy, which is the department of the University of Catania involved in the Sci-GaIA project. As you will see, this Hackfest is co-organized by 3 European Union funded projects. One is Sci-GaIA, the other is Indigo Data Cloud, and the third one is a cost action called ENEL, E-N-E-L. So I would like to give the floor to Professor Piranello just for a few words of welcome to you.
Thank you, Roberto. Yeah, just a few words to tell you that I'm very glad to welcome you here. Department of Physics of Catania is always happy to have events like this, and in particular, I like to welcome a colleague and friend who come from far away. This is especially a good occasion to do this. I hope and I'm sure you will enjoy the meeting, the event, but I invite you also to enjoy a bit of our summer, because in South Africa it's winter at this time of the year. So please feel like if you are at home, all of you, of course, and enjoy the meeting.
Okay, so I think we can go on. I should speak on this one, right? May I go on? Ok. Yes. Dobbiamo cambiare il microfono? Ok. So I leave this here. I need to switch this on, right? Okay. Grazie, Valeria. Okay. May I go on? Okay. Okay. So, good morning once again. I will briefly introduce the first of the 2 projects I mentioned before, Sci-GaIA and Indigo. I will make a short presentation on the Sci-GaIA project, and I'll introduce you the Hackfest, the way we will be working in the next days. And then Giacinto Donvito from INF and Bari will speak about the Indigo Data Cloud project. He will speak by remote, by video conference. So I will give you some concepts, some definitions and driving considerations, and then I'll present the project, the Open Science Platform, and then a few words on the Summer Hackfest. After the first 2 presentations, Bruce will also explain you the social, between quotes, part of the Hackfest, because we really want to have a nice happening where people from different cultures, different countries get together to produce software for scientific applications. So very quickly, what scientists do since almost 400 years is to apply a looping procedure that we refer to as the scientific method. So the scientific method has 2 different aspects at the beginning with Galileo Galilei, and in the 17th century with the inductive reasoning, observing nature. And then more recently in the 20th century, especially with the theory of relativity and quantum mechanics and the standard model for particle physics later, we have the deductive reasoning. So we are trying to extend the theory, and we try to confirm or to validate or invalidate the theory with experiments. And since the mid-17th century, what scientists do, they publish papers. So the onset of scientific publications, dedicated scientific publications, in the mid 17th century, marked a real scientific revolution. But it's almost the same since 4th century. So people publish papers and all the scientific information is done through papers. And also the careers of scientists are based on papers, citations, and so on. The scientific method stands on two fundamental pillars: repeatability and reproducibility of results. The first has to do with the closeness of agreement between independent results, and reproducibility has to do with closeness of agreement between independent results obtained with the same method on identical test material. So scientists apply the scientific method. The scientific method relies on these two pillars. So you may wonder if science is really reproducible. And actually, this is not. It came up very recently in the last few years that lots of fundamental papers, seminal papers in many disciplines, especially medicine, people attempted to reproduce, starting from the papers, but they miserably failed. So in many cases, in almost 90% of attempts failed. And the reasons of failure was that data were not available, the data used to publish the paper, or the software was not available, the software used to analyze the data. Besides this, repeatability and reproducibility, which are the fundamental pillars of the scientific method, are not all. There are other important things. So besides repeat and reproduce science, you should also be able to reuse. So the ultimate goal of producing science is that some other people can take over from what you have done in your analysis, get access to all the aspects of your scientific research, and carry on. So extend the analysis and make additional results. So in the last 30 years or so, the scientific computing evolved very quickly from a centralized approach with mainframe computing up to the 70s, and then to cluster computing, grid computing, and lately cloud computing. And this was possible due to a combined effect of, on one hand, the reduction in the cost of the hardware and in the reduction of the cost of the networks, and on the other end, in the increase of the power of the commercial off-the-shelf components and the increase of the bandwidth of wide area networks, I mean, especially research and educational network. So a new word was coined 15 years ago, the concept of e-science. E-science is science done with electronic infrastructure, with e-infrastructures. So e-infrastructure is a new concept where computing centers and laboratories where experiments are taking data and the data are stored and analyzed are connected through very large bandwidth research networks, and special software that we call middleware is deployed on these centers and make them behave as they were just a single computer dispersed over the network. So e-infrastructure are key to let virtual research communities, groups of scientists spread all over the world across the 24 time zones to access the data, to run the applications, and to use the instruments and the sensors in the laboratories. E-infrastructures are key also to support the scientific method. So this is the scientific method. Is the looping procedure, and high-performance computing clusters, grids, and clouds are very important to analyze data, to exploit existing data, and to archive data. And for the archiving, data preservation and data infrastructures are also important. Data infrastructures, I mean, in the general meaning of open access document repositories, open data repositories, are important to share research data, together with the papers, together with the publications, and let people annotate and produce new papers. And also semantic web enrichment, semantic web technologies are also important to connect different topics, connect data and documents, or different kind of elements of scientific results. The challenge is to walk across this knowledge path both ways. You usually start from the top and you go down to the bottom. So you start from reviewing the literature, running experiments, writing papers, and so on. But we would like to go the other way around, starting from a paper, being able to access the data connected to that paper, the software, the algorithm, and even the possibility to rerun the experiment on cloud infrastructure, on an infrastructure in general. So the very challenging part is going up and down in this knowledge path. This is possible if we apply an emerging paradigm, which is called the open science paradigm. There is no unique definition of open science. I'm listing two that I like and that are very common on the web. The first one is actually the motto of a book, a seminal book on open science, and the other one is was created by a recent report of the OECD that studied the establishment and the uptake of this paradigm worldwide. So open science is a means and not an end in itself. So there is no final or specific recipe to do open science. It's just an attitude that scientists should have to share their data, their publications, and all the elements that are needed to reproduce the data and to reuse the data. So it includes many aspects and stages of research processes, thus enabling full reproducibility and reusability of scientific results. So open science is a combination of approaches. So to do open science, you should have open access to publications, open source software to share, open data, linked data. I mean, if you really want to use semantics to enrich the research output, you should leverage on open standards, and you should so open that also citizen science, so the possibility for people knowing knowing the field but not really working in the research field can contribute. So concepts like crowdsourcing or crowdfunding or research are also part of the open science paradigm. The European Union and the European Commission are heavily investing on open science. There was recently a call for open science cloud for research in Europe that will fund one project up to 10 million euro to create this open science cloud. But in this respect, I mean, in this event, what we would like to exploit is the possibility to extend open science in other regions of the world where actually this concept and also the concept of e-infrastructure are kind new. So after all, open science is about connections, linking people, linking data, linking programs, linking software. So here, there is a map of network links across the world. So you can see the huge connection between the US and Europe, part of the connection with Japan, Australia, Latin America, but you can barely see Africa in the middle. And this is also true when you talk about scientific connections. So this is the maps of collaborations in the field of medicine between 2005 to 2009. So a link is a link connecting authors of papers on PubMed. So you can see again the strong connections between the part, and you can see that there are very few connections with Africa. And these two maps are even more striking. This is the map of the world rescaled by the number of documents in Web of Science published by authors living in the country. So you can see how fat are the northern hemisphere, and how slim is Africa, for example. And this is the map scaled by the number of journals published there. So there is a challenge, make African science and scientists more visible. And there is an opportunity to exploit e-infrastructures to do that. That is actually what we want to do. And the vision is to promote open science in Africa to make African science and African scientists more visible. So the Sci-GaIA project is just about that. We want to leverage on e-infrastructure concepts like science gateways, like data infrastructures, to promote open science in the continent. The Sci-GaIA is funded by the European Commission with about 1.4 million euros. We started a little bit more than 1 year ago, so we have 10 months to go till the end of April next year. The project is coordinated by the Brunel University and has key partners, European partners and African partners. And we have the two regional research networks, namely UbuntuNet Alliance on the southeast and WACRN on the southwest. This was done in purpose to have as partners of the project organizations that can act as interface towards lots of universities and research institutes all over the continent. So the idea is to propose structured guides and educational documents to foster national research networks and to support national research networks and communities of practice in Africa to make their science more visible. So there are different work packages. One of these work packages is about training. We ran in the past months an online school, and the Hackfest is actually one of the most important training events in the lifetime of the project. Sci-GaIA is strongly committed to promote open science, and we recently created the so-called Dakar Declaration on Open Science in Africa that was announced at the Sci-GaIA workshop in Dakar, Senegal, 3 months ago. This has been signed already by, was quite old, I mean, we have almost 130 signatures, and the Dakar Declaration has also been signed at the institutional levels by different institutions from Europe and Africa. And we invite all of you to visit this page, and if you share the concept and if you share the way the declaration has been exposed, we kindly ask you to digitally sign. Just fill a form and submit and confirm your signature clicking on the email. But we went beyond general consensus on open science and general promotion of open science. Using tools and services insisting on e-infrastructures, we created a federated platform made of commons, science commons, for open science in Africa. So this is explained in this other page, and several of the services that will be exposed and will be explained during this Hackfest are part of the open science. We have, in the open science platform made by Sci-GaIA, we have several services that are put together and orchestrated, but other services, especially those developed by the Indigo Data Cloud project, could be very easily plugged in and extend this open science platform. Each of the services can be cloned. So you will be using services in that we deployed for Sci-GaIA, but if you are interested, each of the services can be cloned at your organization, and you can install it and use it for the purpose of supporting your community. We managed to implement the knowledge workflow, and actually this is what we would like to enable for your use cases as well. So the idea, you go clockwise on this picture, so researchers or citizen scientists can search and discover documents, but not only documents, they can discover all the objects that are needed to reproduce that particular scientific product. So the paper, the data, the algorithm, the program, even a complete virtual machine or a container that can be rerun on a cloud-based infrastructure. So you can use the science gateways, so high-level portals, to run the analysis, starting from the papers you have found. So you can reuse the data, you can extend the scientific analysis, you can produce new results, and then you can write a new paper and publish on the open access repository and link the new paper to the old one. So you extend the ensemble of elements of our research product. So that's the idea that we have, and we will demonstrate all the different components, and then we will let you try these components. And the idea is that you may leverage on one or more of these to implement the use cases you proposed when you applied to be selected for the participation to the Hackfest. So, as I said, the eResearch Summer Hackfest is an event where we want to bring science to the web and the web to the science. So we really want to use web technologies to make science more visible and also life for scientists easier to produce and reproduce and reuse scientific components. So the Hackfest will go on in the next 2 weeks. Actually, we got lots of interest from African partners, and several of them could not come due to problem in the issuance of visas. So we decided to run this Hackfest twice. So we will be running in the first 2 days, and then we will record everything. Then people will come at the end of the second week, and we will run another time in the last 2 weeks of July. Of course, not all the instructors may be present, so we will, for some presentations, we will rerun them. For some others, we will use the video recordings. So the event is co-sponsored. Co-sponsored means in terms of instructors, in terms of participants, and in terms of projects and use cases by 3 different European Commission funded projects: Sci-GaIA that I presented, Indigo Data Cloud that will be presented by the next speaker, and cost project ENEL. We have some representatives here, and other people will come during the week. So the main objective is to integrate scientific use cases, those use cases that you proposed, through a pervasive adoption of web technologies and standards, and make them available to their end users through science gateways, portals, desktop applications, any kind of high-level interface through which people can run the applications that you will be developing in the next days. The ultimate goal is to promote and foster open and reproducible research, and this is why we will expose we will leverage on the Open Science Commons concept. So we have very interesting topics and several tools and technologies that will be explained already this morning and in the next day. So the idea is that you propose the use case, you came with the use case, and since we are leveraging on web technologies, we will show you RESTful APIs, REST interfaces, through which you can use the services and the tools that we will explain in the first 2 days. So all the tools, the common denominator of all the tools that will be explained is that they have a REST interface. So using the REST interface, you can use these tools, more than one, all of them, in implementing your use case. And the services are deployed on an infrastructure, actually on more than one. We have the Sci-GaIA infrastructure, we have the Indigo testbed, so you will be able to test the tools on a real environment. All the presentations in the first 2 days will have end zones parts, and at the end, when you will be actually coding, implementing your applications, you will be accessing real e-infrastructures. The agenda. So today and tomorrow, we will present two technologies and tools, those that are listed in the agenda page, and you have seen already when you applied. And for each of them, there will be theoretical introduction and hands-ons. So you will be able to use this, to run this on your computer. Then on day 3, we will be listening to you. So each of the use cases will be presented. I distributed some template for this. You are welcome to use it. Otherwise, you are welcome also to use your own. But we would appreciate that you indicate the technologies and the tools that you plan to adopt. So you will be listening to tools. You will be listening to how to use them. And then what we expect is that on Wednesday, you will tell us, I want to use this. I would like to use that. I plan to use that one. Because in that case, it will be easier for us to redirect you to the developers of these tools and to short-circuit the contacts with the developers to improve your support. The other days, people will stay only 1 week. There will people stay for the whole 2 weeks. But the other days, there will be implementation of the use cases. So we choose this big room on purpose. So in the first 3 days, you will be listening to us. In the first 2 days, you will be listening to us. In the third day, we will be listening to you. And then from the 4th day on, you will be scattered around and you will working on implementing the use case that you proposed. So that's the idea. Just to summarize, the open science vision can be implemented only the openness paradigm becomes pervasive in day by day research, and this is possible only if you can use open tools, and this is what we will be showing you. Science output reproducibility, but also reusability and extensibility are key to walk through the knowledge path in both directions. So you will be able to connect papers to data, to algorithm, to virtual machines or containers to rerun all this. And the Sci-GaIA project is strongly committed to promote the uptake of the open science paradigm and its building a viable federated platform. Federated means that all the services of the federation can be used using federated credentials. So if you have federated credentials issued by your organization, you will be able to get authenticated in all the services that we will be explaining. If you don't have such credentials, we have a catch-all identity provider, and we can issue a couple of credentials, username and password, in minutes. So if you need it, we will explain you how to get these credentials so that you can get authenticated. We would like to have this as a scientific, technological, but also social attempt to exploit web technologies. Bruce will jump in after the next presentation. And we want to exploit, as I said, the web technologies to uptake the open science paradigm in a truly international and multicultural environment. So that's it for the first presentation. Thank you very much. And if you have questions, feel free to ask. Any questions? Comments? Yes. Yeah. Can you just introduce yourself? Because many of us don't know each other. So if you can just spend just 2 words to introduce yourself.
Okay. I'm Professor Benjamin Aribisala from Lagos State University in Nigeria. I'm an expert in brain image. My question is about the tools that will hypothetically come out of the Hackfest after the development. The end users, will they need privileged access to be able to use them, or will it just be open to everyone?
Well, the authentication will be based on federated credentials. The authorization will very much depend on the application. So what we would like to listen from you on Wednesday is if your use cases have particular authorization aspects. So if the use case that you are developing or you plan to develop are open usable by everybody, or you have, for example, in case you manage medical images or physical records, if you have stringent authorization rules. We can implement also authorizations. Of course, authorizations in the end is something that is managed at the level of the use case. So you should tell us if your use case is completely open or we should follow strict authorization rules. Yeah.
I'm Mr. Zdal from Austrian Academy of Sciences, working at the Institute for
Okay. Let me, so that otherwise we will not hear us from the
Thank you.
from the stream.
I am Ostojić Davor from Austrian Academy of Sciences, working at the Institute for Digital Humanities as a software developer. My question is, you said that we can use and adopt tools and services you are providing to us, but can we also offer our service to you? Okay.
Of course. So the Hackfest is really a human happening and also a technology mashup. So on Wednesday, you can tell us what are your, I mean, I guess that in your use case, I mean, you may have use cases or you may have very consolidated applications. For those very consolidated applications, you may already use some other services. Share with us. But the underlying paradigm is that they should be open. We should be able to share at the level of the source code. So, for example, we kindly ask all of you to have a GitHub account. Whatever software you developed, they should be visible somewhere on a GitHub account so that we can easily share. Sharing doesn't mean that you share and everybody can do whatever you want. So you also decide the open license that you will apply to your code, to your services. All the services that we will be explaining are the software services are released under Apache 2 or GPL 3 licenses, and all other things, data sets, papers, reports, are released under Creative Commons licenses. So these are the two kinds of licenses for software and for something else that we apply, and we guess that you also have this kind of license in your use cases, in implementing your use cases. Any other questions? Okay, so if not, we can move to the next speaker. Giacinto, can you hear us? Giacinto, you are muted.
Yes, I can hear you.
Okay, so let me prepare here. I'm increasing the volume of your microphone, and we put the other microphone next to my computer. And if you can just introduce yourself half a minute, and then the floor is yours.
Okay, thank you.
Let me put the slide. Sorry. I want to put the slide in. Okay.
Okay. So, just good morning to everybody. Jacinto Novito speaking from European Body. Just please forgive me to not be there, but tomorrow I have another meeting in another place, so it's difficult for me to travel around. So I will try to give you a brief introduction about the Indigo Data Cloud project. Most of the things that I will show in this half an hour will be better presented by some colleagues of the project.
Jacinto, sorry to interrupt you. Actually, we are streaming very well by your voice, but in the room using my computer. So we are looking for the loudspeaker. So I would kindly ask you to wait 5 minutes, not more than that. We are taking some loudspeakers so that in the room your voice can be much louder. Okay?
Okay, no problem.
Just a couple of minutes. So we are taking some speakers to make your voice louder.
Okay, I also increase the gain of the mic
Yes,
from my side.
that would help actually.
Okay.
Let me also start recording the meeting. Okay, so we can also have the video of your presentation. Okay. Ok. Ok. Dammi qua. Mettile qua. Mettile qua. Questa una va alimentata, giusto? Sì. Ok. Aspetta, mi devi dare. Giusto, posso spostare più avanti. Mi devi dare il microfono semplicemente. Una va là, giusto? Una va là e una va qua. Giusto? Una va qua. Aspetta. Giacinto, try to talk.
Hi Roberto, can you hear me?
Very well, you are online. Okay.
Okay, thank you so much.
Maybe it's too much. Just a moment. Let me. Keep talking. Keep talking.
I have lowered down again the gain because maybe that's something distorted.
That's perfect. The floor is yours.
Okay, thank you. So, good morning again to everyone, just to be sure that anyone catch all the audio now. And sorry for not being there, but I was already busy in another meeting tomorrow, so it's difficult to me to travel around Italy. And I will try to give you a short description of what Indigo Data Cloud project is building. It will be very high level, and I will not put so much details on each of the technology and services developed, because most of those services and technology will be better described, and also you will have some demos and hands-on on the next hours and days. So starting from the next presentation is in the agenda, and also the afternoon and all tomorrow, you will see a lot of concrete details on how all those services are implemented and how they work. So my duty here is to give you an overall view of what the project is, which kind of platform we are thinking in order to help scientists community to build their own science. So going to the second slide, just a brief introduction about the project. It is a European-founded project in the Call Infra 1 2014, and it was started April 2015. It will end in September next year because it's a year-round project. It is a very huge effort, both in terms of money invested by European Commission and both in terms of partnership and distribution around Europe. So we have 26 European partners and 11 countries involved. That obviously, as still the name already tells, is mostly related to cloud and data analysis. So we are trying to put on the ground a cloud platform that is able to let the scientists do their data analysis. So it's perfectly intended and architected in order to let the scientists exploit that. So it's not a general way of giving cloud services. It's perfectly targeted for the scientific communities. And indeed, we start from the requirement coming from the European community of scientists in a lot of different areas, starting from structural biology or science or physics, bioinformatics, even cultural heritage, astrophysics, etc. So, lot of people and a completely different group of researchers are providing us specific technological and scientific requirement in order to focus and to steer our development. So it's something that starts from the needs of the users. It's not providing technology just because we like the technology, but they start from the requirement and then going back to the technology, try to find out which services, which components are really needed by each of the community, and so try to bring together and to make a coherent platform that could be used by any of those scientific community. But already we are targeting scientific community that are not listed in the project since the beginning, because obviously if the platform is general as we want to be, we should be able to serve also diverse community. So we started from our perception of what is missing the already available cloud technology. And by incident, we found that we are not alone in these thoughts. And we see that, for example, European Commission in this paper that we are listed here, it's somehow telling the same that we are thinking before. So they are already stressing the fact that in many cloud technology, there is technological gap that should be filled. For example, from point of view of the interoperation, or from point of view of the multi-tenancy, so the isolation, the capability of providing isolation when needed, or for example in terms of elasticity and dynamic allocation of resources and all other stuff. So which kind of gap we try to fulfill in the already available cloud technology? Mainly we are focusing in providing redundancy and reliability for both services or application executed over the cloud, together with the capability to provide to those applications or services the needed elasticity in terms of scalability. So basically you can exploit the number of resources you need exactly instead of allocating those resources before ahead and need to somehow pre-fetch resources in some way, manually or whatever. Also monitoring the resource utilization of those resources. And so both the site admin and user are happy with the share of usage of resources and the dynamic allocation of resources. Obviously, one important thing is avoid to be a commercial provider, but also in terms of technology. You should be able to change the technology underneath, also if it's open source, without worrying of building a game from scratch the full platform. So just to give you an example, we should be able to deploy any kind of software or services we have, both on OpenStack or OpenNebula, in a very transparent way from the user point of view. So the end user should not know which kind of cloud technology we are exploiting. And this means that we are avoiding any kind of blocking. And also the application is somehow already there. We cannot think that the end user will rewrite all the application they have just because the cloud is smart or the cloud is trendy. We should try to move all the application we have in the cloud in the more seamless way as possible. And so a lot of application and a lot of services is perfectly intended to solve this kind of problem. Obviously, as we are dealing about science and the data analysis, we really need big data analysis, big data exploiting HPC resources and whatever. Differently from the past experience, don't want to reinvent all the wheels, because we already know that there are a lot of projects that are there producing good software and perfectly usable technology. So we want to have anything that's already there, improve it if and when it's needed. And as soon as we do some kind of improvement or addition from the point of view of the feature, we should push this into the project back again, so that it's automatically maintained also after the end of the project and if the developer is gone. Because obviously this means that solution, that services, is sustainable for the futures, and the scientists and community could leverage those services for a very long time in the future without worrying about what is about in the data cloud. Obviously, we are not alone in the world, both in terms of project and infrastructure. So we know about a lot of other projects that are dealing with the science or with the technology, and we are collaborating very closely with them, both in terms of scientific community, as you can see in the slide. A lot of infrastructure is somehow joining the project or working with us in order to have their use cases in our platform. So Elixir, WMR, or I don't know, Eurobioimaging or whatever, but also in terms of infrastructure. We are working closely with the GI, with the UDAT, with ARC, and Praise2 in order to have solutions that are somehow interoperable, that can work together, and that at the end user could exploit the services where they are available, not worrying about, oh, okay, this is Indigo only platform, I cannot use anything about UDAT anymore because I'm switching to Indigo. So we want to have a solution where any kind of services could be plugged in and could be interoperable. For example, before I had someone is asking if I can bring my own services or my own software here. Surely you can, you should try to have this kind of mixing environment, because this is absolutely welcome and this is good for anyone to work together. Obviously, as a project, we are working with a work package approach, and free work packages is specifically devoted to develop services, both at the level of infrastructure as a service, WP4, that is dealing about resource virtualization, or at the level of platform, so federation, automatism, etc., that is WP5, and at the level of portals, toolkit, interfaces, that is WP6. In the next talks, in these 2 days, you will see mostly things coming out from WP6 and WP5, because the functionalities and the services that are at the level of IIS usually are not so visible from the end user. They are mostly devoted to the cloud providers in order to improve the reliability, the performance, and whatever at the level of IaaS. But you are already exploiting them without even knowing that there is some advantages in using Indigo specific IaaS instead of the general one. So it's something giving you for free without even knowing that you are exploiting them. And then we have a work package devoted to the collaboration with the research community, and then obviously the software management and pilot services that will be free. So this is a very simplified sketch of our overall platform. As you may see, it's quite complex. Also, if we try to simplify a lot the interaction and the number of services. Mostly in the bottom of the picture, you will see services coming from the resource virtualization layer, so basically the IaaS part. And with the yellow box. With the red box, you will see most of the services that are devoted to provide PaaS-like features. With federation of storage and computing, brokering of cloud resources, authentication, and other stuff that I will describe better in the next slides. And then obviously the upper layer, it's mostly devoted to toolkit interfaces, portals, and similar technologies. So starting from the bare metal, here in the next two slides I will list some specific feature that we are working on from the point of view of infrastructure as a service. As we are obviously targeting only open source software, from the point of view of the infrastructure as a service, we are working on OpenStack and OpenNebula, because obviously they are quite close to our community, and we can put hands on and change the code and provide this code to the upstream of the projects, both. For example, one of the most important achievements is try to improve the scheduling capability of both OpenStack and OpenNebula in order to allocate resources. If you know what is a batch system, you know that you can have a kind of share or priority in exploiting batch resources. This is not already available in the cloud, but we are pushing new services and code in order to explicitly provide those features, so that you can ask for a cloud resources, and you may have a very similar behavior to what is before I had in the batch system. So your request is put in a queue, and your request will follow the definition of quality of service or share or whatever that your infrastructure provider is giving to you. So you may have a very golden and fast and quick response, or you can just stick in the queue. As soon as some free resources is available, you will get that. So this is a very important implementation that we are working on. It's very close to be released officially. From the point of view of the orchestration, if you have any experience on exploiting directly a given IaaS, you know that there are a lot of steps that you need to do in order to have a full running services. So you need to ask for a virtual machine, to plug some disk on top of it, to configure the network, to start the services, to configure the services or whatever. All those steps could be orchestrated, could be somehow automated in a way that the user is not worried about any of those steps. Both OpenStack and OpenNebula has some features that give the possibility to orchestrate resources, but we are working in order to harmonize the languages that we are using in order to do this orchestration. So now we are stick with the Tosca, that is a standard, and it is a widely used languages. So you may use OpenStack or OpenNebula, and you don't change any comma in your template. So it's perfectly running, the same template is perfectly running on one infrastructure or the other in a very transparent way. In the next slide, we are also looking to the storage technology. We are also improving the capability of describing which kind of requirement you have from the storage perspective. So you may ask for a very reliable storage and a very cheap one, like registering those files on a tape that will stay for 10 years, and we will not lose the data, but it will not be so fast because you just don't need that file every day. Or you may do the opposite one, asking for staging them in a very performant SSD disk for a limited amount of time. So these kind of features are somehow already available on the commercial cloud provider, if you look at Amazon Glacier or Google Cloud Storage, etc. But it was not in the open source cloud technology. We are exactly filling this gap, so that also in open source cloud environment, you may ask for quality of services in terms of storage capabilities. Also, from the network perspective, we are improving the capability of both OpenStack and OpenNebula in order to fulfill requirement about isolation or building up VPNs or spanning the same network on different sites, etc. Also, as we are dealing with the science, most of the time you need performance very close to what the bare metal is able to do. And the best way to exploit this is container running on bare metal. So we are improving the transparency of using a container in a cloud environment so that the user can push their container into a public Docker Hub repository. This will be automatically available at the level of IIS without asking anything, and just run your application in a very transparent way with the maximum performance, and maybe exploiting, I don't know, InfiniBand or GPU card or whatever you need in your application environment. So this is most of the most important services at IIS level. From the layer of the platform as a service, I will go much faster here because you will have a more detailed view in the afternoon about those services, and also tomorrow about the search part. Mostly, we are improving the capability of exploiting in a geographical environment the cloud resources. So you can ask to a single federation of sites to deploy your services, asking for certain amount of resources or certain configuration of the IIS or whatever, closest to the data that you have, or any kind of different requirement that you may have. And the system is able to find...
Sorry to interrupt you.
Yeah,
you are
please.
still on slide 8, because we are on slide 8.
In my share, I'm 10. I was 10.
Let me...
This pass feature, the first pass features slide.
Okay.
I don't know. I see
No,
the
no, no, go ahead,
streaming.
go ahead.
The streaming is...
Okay.
So from the point of view of the brokering, the pass layer is able to broker across different resources from the point of view of the computing and storage, and so let the people know, exploit automatically which is the solution that fit better its requirement. From the point of view of the interfaces, again, we try to use a standard way of assessing software or resources. Again, here the means is a Tosca template that is standard definition, and so that the user could define the requirements in terms of software, in terms of dependency, and so you can have a very complex way of describing your cluster or your needs in terms of application. And this is somehow quite general. It could be used across any kind of cloud solution. Even using the PaaS layer, even you can exploit, I don't know, Amazon or Google, and this is completely transparent to the end user. So the PaaS layer is taking care to translate this high-level definition of cluster of services into something that is understandable by Amazon, by OpenStack, by Google, and whatever, in a very transparent way from the end user perspective. From the point of view of the storage, the slide 11, we are building a data federation that is able to provide you the capability to share any kind of storage solution. So you can exploit POSIX file system, you can exploit object storage, you can exploit different kind of vendors storage technology, and then you get a unique federation layer where all your files is somehow accessible also via a standard POSIX environment. But you can, if you want, also exploit high-level features like quality of services I was describing before. So you have a very high grade of flexibility, and you can express your needs in terms of storage in a very high-level way with web interfaces and all those kind of stuff. You will be also able to share your file from your desktop in a very easy way, like Dropbox or whatever, and then push those files into a cloud, keeping synchronized with your desktop if you want, or not, depending on your requirement. And these files are automatically somehow available in the cloud for your application to be executed. Also exploit kind of dynamic caching mechanism if you want to exploit those files in a site that is not keeping that data in a reliable way. For example, from the automation and exploiting of scalability of resources, we are providing kind of solution in order to let the services exploit how much resources they need with a kind of automatically monitoring system. So you don't need anymore to ask by yourself in order to get more resources, but the services is monitoring, and if it consumes all the CPU available, you will get new CPU if you are configuring the system to scale up to a given limit. So you can just provide to the web interfaces the limit that you want to pay, like from 5 CPU to 50, 100 CPU, and then the system will automatically scale up to that limit, depending on your configuration. This is already available for Condor, Torque, or even Apache Mesos cluster. That is something very high level that exploits the possibility to provide services together with the application. And you will see about those features and technology in the afternoon presentation about PaaS layer specifically. We are also working a lot in terms of providing AI features. Mostly all the people come with a home account, like your home EDP or your social account. So we are willing to provide all users with their own account, an account in our cloud platform. So you may end up with the SAML, OpenID Connect, X509 credential, and we can harmonize all those credentials and let you exploit all the cloud services that we have in the portfolio in a very transparent way. But centrally, you can define things like membership or authorization for exploit some services, etc. So this is very flexible from the user perspective point of view, but you can easily access already available services, for example, that are not able to understand an OpenID Connect account. This is done by Indigo itself, and there is the specific services that is able to do this kind of translation automatically. I will not go in too much details about the storage itself, but what I want to stress here is the fact that we can provide now, together with the quality of services, the capability to provide data lifecycle management. Like I have those data that I want to analyze for the next 6 months, but after 1 year, they are not needed anymore for my analysis. I can store those data in a tape and then, for example, make it open data automatically. So all those kind of changing of quality of service is automatically dealt by the system if you configure that way. and this is named data lifecycle management. Oh, fortunately, here there are some problem with the translation, but anyway, you can see the slide in your PDF file if you download from the web. Anyway, looking into the very higher layer, basically we deal about the possibility to build your own gateway or your own portlet in the gateway, because we are providing REST APIs, toolkit, and obviously an already available front end that you can use in order to push the portlet. But obviously this will be very well described in the next slide, so I will not go into much details about that. But I want only to stress, as Roberto mentioned before, that now any kind of capabilities or any kind of features that the platform is enabling is somehow available as a REST API. So you can easily exploit this even in your own already available portal or workflow manager, etc. We are also building tools in order to do big data analytics, and I guess this will also be part of the discussion you will have in the next days. This is specifically related to the high-performance computing environment. For example, if you have an already available workflow mechanism like Kepler or, I don't know, Taverna or whatever, you can easily plug Indigo features, call it like that in your workflow, just calling a simple REST API. So that's the very advantages here, because you don't need to implement any kind of specific library or whatever. It's very transparent and straightforward. So let's go to some example of use cases, how this could be put into production. So just to make an example, looking into a workflow system mainly used for bioinformatics community named Galaxy. This is able to deal about the offload of some application into a batch system that is configured automatically under the web interfaces that you see when you log into the portal. And also at the level of the portal, you are able to deal with user credential and isolation of the user, whatever. So basically, this is an already available solution. We cannot change it, because obviously this is not part of our project, and we cannot ask them to do strange configuration of the software. So we need to put this into our platform as transparent as possible, but trying to exploit our features. So this is a typical example. Just don't change the application, just put that into a cloud environment and try to exploit what is already provided by the cloud platform. So what will be provided? A Galaxy web frontend automatically installed and configured, so with a public IP that you can reach on the public web as they are used to do. So basically the very end user don't see any changes in their workload. The only things is that someone before, like the group administrator or the sysadmin, should ask to Indigo to deploy those services, but it's not somehow visible from the end user perspective. The interesting part is that we want to deploy together with the web frontend also a batch system underneath that is able to process the data and to run the application in a very transparent way, dealing with the different amount of load that user could put into the system. So if they submit more job, the batch system will increase the number of the nodes automatically. And both the web frontend and the worker nodes need to share the same shared file system. And this should be configured automatically. The user don't want to change a bit or to increase the complexity of running this application. So, what is needed? We need to start a template in order to define all those services, to put all together this orchestration of the services, and this is done just once at the developer level, together with the developers from WP5. And as soon as this is already available, the end user could just exploit these services or ask for distanciation of a new services, just choosing the template from a web menu and configuring the number of nodes they want to have as limit, upper limit and down limit. Unfortunately, also the next slide looks empty to me, and this is very weird because this is somehow quite important. Sorry about that, but
Do you want
I
me
can
to show? Do you
skip
want me to show the
and
slides
go
locally?
to. Okay. Fortunately, also slide 31 is somehow
Giacinto?
broken. I don't know, Roberto. This is
Josh,
a bit problematic.
I
but
can show
anyway.
you. Let me. Okay, let's do like this. I'm stopping sharing and I'm sharing the slide myself, and you will steer from
Yeah,
from
thanks.
remote. Okay.
Yeah, thanks. If
Okay.
you go to slide 31
Yes.
only, that's enough. I will
okay.
show only that one.
Okay. Let me. Okay. Okay. You should see my screen now.
Yes.
And now I'm gonna start your presentation. Let me go. Slides. Okay. I go Control L. And I go to
31.
31.
Okay, that no.
This one.
The bit after no, it's no 31.
Let me. This one.
No, a bit before. Yeah, this one.
This
Thanks.
one. Okay.
No.
Okay. So I go Control L, and you should tell me next slide. Okay.
Next slide, please.
Okay. Okay. Next slide. Okay.
Okay, that's perfect. So here you see from the left of the picture, here we see that we need to build this kind of Tosca template once, decide how to orchestrate all the services, push this Tosca template and the Docker file into a repository, official repository, and then this is available. An end user could just choose the Tosca template and start up the services from the portal, the Future Gateway portal that you will see, and then using and exploiting all the layer of the Cloud Indigo platform, these services will be deployed on a given infrastructure as a services with a web front end and together with them a private cluster of worker nodes. We will monitoring the status of that cluster and automatically ask for new resources if this is needed. And the worker nodes will be automatically installed and configured, and they will join the cluster automatically. So what the very end user see, the people in the top of the picture, is only the Galaxy front end as it was before. It can push data using a one data solution that you will see tomorrow, I guess, and those data are automatically available in the Galaxy front end, and so also to the worker nodes, and it will get the data out as soon as the application is executed, as easy as it was to push the data in. So it's automatically dealing all the complexity of using a cloud infrastructure. If you go next slide, please, I will go very quickly to another example of integration. So this is related to an already running European project that is building a very complex infrastructure solution based on Mesos. That is a resource sharing Docker solutions, and you will see a lot of details about this in the afternoon. But the example here is that they are already building their infrastructure, and they don't want to change this because it's an ongoing project. We plan to push all those services into Indigo as a whole, just providing a new Tosca template that could be instated automatically, exploit a lot of features and capabilities we are providing to the youth. So all the work that they have done is one specific template in our app. And they will get for free the AI part, the data management solution, the auto-scaling of resources, the capability to deal with the brokering of different AIS, etc. This is automatically available also if the platform is already there. We can just put the platform into our solution and just let him run as it was before. So that's the most important approach that we are trying to push to the user community. So if you go next slide, please. Okay, this is a graphical example, very similar to what we have already. Maybe we can go to the conclusion. Roberto, it's slide 32. We can skip with the Indigo focus.
Okay.
I guess I'm running out of time. Yeah. So we will officially release our software end of July, first day of August, and so there will be available to general public. But a lot of already available services or components are there and could be somehow exploited for testing purposes in a prototype form. And a lot of people in the room are already starting make some tests with these services and platform, and this will be more true in the next weeks. So please try to look into these services and this approach and give us as much feedback as possible in order to improve our approach, to try to implement better some services in order to fulfill your requirements, or to just try to steer better our way of providing services, because obviously what we really need is feedback from the very user community, because we want to produce something that is somehow usable for you, that you are producing science. It's not for just joking with technology. It's really to try to put in your hands more instrument, more toolkit that you can use in order to provide better science in the future. So we are really willing to have your feedback. So try to push your feedback to the technical people that will be there in those days, in order to let us improve our approach and our services itself. And that's mostly what I want to tell you. If obviously there are questions or comment or whatever, I'm happy to try to reply.
Thank you very much, Giacinto. Let me stop sharing. Any questions to Giacinto? You can raise from everywhere. I can repeat for Giacinto if there are questions. Okay. Yeah, there is one question.
Okay. Thank you very much, Giacinto. You mentioned about giving us licenses on the tool. My question is, would there be a lifetime for the lifespan for the license? Are we able to use it for maybe a year, or will it be open-ended?
Giacinto, you heard the question. The question is about the lifetime of the license. What is the extension in time of the license of Indigo software?
From the license point of view, we choose Apache 2. Mostly because a lot of software that we are exploiting is based on Apache 2, so that's the easiest way to deal with mention. We have 4 big industries in our partnership.
Copia e pure F7.
F7, ecco cosa avevamo fatto.
Tu dai, se metti il bottone blu, lui si mette sotto, ma per avviare devi cliccare o avvia col bottone destro oppure con F7.
Ok. È ripartito, ok.
È male, è buono.
Ho messo quello lì.